Determine if the following series is convergent or divergent. So we got a series here. These are general terms, so ANs 1 over n squared plus 3n plus 5. Let's try to find a new series whose terms are similar to an. Okay, and that series should be a much simpler than this. That is just taking the leading terms on the top and bottom, so 1 over n squared. So let a new series will construct a new series whose terms are just the leading terms of an, so 1 over n squared. Now we know that series with 1 over n squared, and let's match the same n's, n from 1 through infinity, converges or diverges. 1 over n squared, this is a p series with p2 which is bigger than 1, means this series converges, not that this converges. Okay, being a p series with p equals 2 bigger than 1. Now, since this series converges, if we are able to show ANs are smaller than BNs, then this series also converges. We are trying to show this guy, BNs are bigger, okay, this big guy, and we are trying to make smaller, ANs is smaller. And we know that if bigger guys converge, then smaller guys also converge. That's what we want to show here now. If ANs are not less than equal to BNs, then the direct comparison test does not apply. Okay, this one is kind of our bigger guy, and this bigger guy converges. Now we want to show this guy being smaller than BNs, then by direct comparison test, smaller guy also converges. So need to show ANs are less than equals BNs. Okay, it is true. So let's plug in here. So an means 1 over n squared plus 3n plus 5. Is this less than equal to 1 over n squared? Let's see. Let's cross multiply, and this n squared times 1 n squared. This is true if and only if the following: n squared plus 3n plus 5. Look, for n bigger than equal to 1, this right hand side is bigger than n squared, because we'll be adding 3 times n plus 5. That's true. That means this bigger guy converges, being a p series with p bigger than 1, then this series with the smaller guys also converges. Then by the comparison test, it's kind of direct comparison test, the given series also converges.